In this lesson, we're going to learn how to orchestrate the movement of data between multiple different workers directly. In order to do this, we're going to realize that we can actually extend the pointer framework that we were using to manipulate remote data and actually have pointers to data. Let me show you what I mean. First, let's take our Bob and Alice workers and clear out all the objects on them. So this just simply deletes all the tensors that happen to be on Bob and Alice that might be around from previous exercises. And then let's create some data that we can then start to work with. So let's say x equals torch.tensor 1, 2, 3, 4, 5. So this is just a normal tensor, so as we've been working with before. So the first thing, let's take this and let's send this to Bob. So now we've got a pointer to it, and Bob has this object. But now we're going to do something else. We're going to say x.send Alice. And what this does is actually sends this pointer to Alice and replaces x on our machine with a pointer to that pointer. So now if we look in Bob objects, well, that data hasn't actually moved. But if we go Alice.objects, now we see that on Alice's machine, Alice has a pointer from Alice to Bob, and our pointer no longer points to Bob, instead it points to Alice. So whenever we were to send a message to contact this tensor, to use it to add two tensors together or subtract, the message would first go to Alice's machine. It would then be processed there, which would call this pointer, and then this pointer would then forward that message to Bob's machine, where it would actually be executed up here. So let's see an example of that. There it was. So now we have a new pointer. This, again, still pointing to Alice's machine. And if we look inside of Bob objects, we see that now there are two tensors on Bob's machine. And if we look at Alice objects, we see two tensors as well. However, this time, both of them are pointers. So the interesting thing to note here is that the new pointer that was created, or the new tensor that was created, has the exact same pointer chain, same dependency chain, same ownership chain as the original tensor that it was used to create it. So when we said y equals x plus x, x has a certain dependency chain, right? So x is sort of owned, you can think of, by both Alice and Bob, to the extent that we, as the central server, cannot actually contact that tensor. We can't use that tensor, we can't do anything with that tensor unless both Bob and Alice allow us to, right? Because we could send a message to Alice, and Alice could say, I'm not forwarding this to Bob because I don't want to, right? For various reasons. Maybe it's privacy, or just doesn't want to, or doesn't know where Bob is anymore, who knows what. But alternatively, Bob could also say, no, I'm not going to allow you to perform this operation. So in a sense, both Alice and Bob are actually joint owners over this one digital asset. Now this also leads to sort of the second internal conclusion, where if we were to try to, say, do an operation between two tensors that did not have the same chain structure, it would lead to an error. So let's say, let's create this tensor chain again, and let's have another one called y. So we sent this to Alice, send, do we have a third worker? Let's make a worker called John. There we go. Z equals x plus y. As you can see, because this was using tensors where the actual data, the data is on Bob's machine. That's where we sent it, right? So the data is in the right location, but because John and Alice disagree, they don't have the same ownership structure along the way, this can trigger an error. Now, the next thing is, how do we get this data back? Well, since we have a pointer to Alice's machine, if we call .get, then we actually get the pointer from Alice, and now we're pointing directly to the data again, right? So let me actually show you that this actually removed the object from Alice's machine. So let's clear these objects and reset up this experiment just so it's clean, so that we can see it. We don't actually need this other tensor for right now either. Okay, so now Bob and Alice each have a tensor. Alice's is a pointer tensor, Bob's is the actual data. So now if I call x.get, then we look at these again, Bob still has the actual data, but Alice no longer has the pointer because she sent it to us. And now we are pointing directly at Bob's data, right? And so then if I were to call x.get again, we would actually get the data back. And now Bob has no data. Beautiful. So I hope that this interface really feels intuitive to you, right? We try to make this as simple and easy and natural for the average PyTorch user as possible. And all the things that you sort of expect to work indeed work. And the other thing that I think you should take away from this is that pointers are actually first-class citizens. Like, they are tensors for all intensive purposes. They have IDs, and so you could do a pointer chain here that is 50 people long if you wanted to, and it would pass all the messages along as you specified it. And even actually, one thing I didn't cover yet was a garbage collection. So let's say if I create this tensor, it's on Bob and Alice's machine, and then I go delete X, and then we look at Bob and Alice's machine again. As you can see, garbage collection collected the whole chain, right? Because it sort of assumed that since we deleted the pointer, that it should delete the thing that we were pointing to. And when it deleted that pointer, then it should delete the thing that that was pointing to, right? So the nice thing here is that, again, just like with the other tools we were working with before, we can do federated learning or other complicated algorithms, and in theory, the default behavior for how objects are collected will prevent memory leaks and memory explosions, right? From objects getting sort of just left around. And yeah, so that's this nice tool. And what we're going to be able to see in the next lesson is how we can use these pointer chains to actually orchestrate how data moves amongst a group of workers, right? So instead of just calling send and get, we're going to be able to actually move data around directly, like telling Bob, hey, send this data not to me and then I'll send it to someone, send it directly to Alice, for example. So in the next lesson, we'll jump into that, and I'll see you there.